Alright friends, a very good evening to one and all. Here we are back again, resuming the data analytics bootcamp after a long time. Okay, fine. Very quick revision of not all but few of the topics to name them that we have covered up so far. Firstly, I hope you all are doing well, good, and might have practiced Python a lot. Okay, with this break of say, some number of weeks and months. Alright, anyways, let's still continue. Okay, we started with Python. We learned the concept of variables, operators, conditional statement, loops. Alright, we also moved on to some advanced data types of Python, which was list, tuple, set, dictionaries. Is that right? Okay, fine. Alright, then we also discussed some more advanced concepts of Python like exception handling. Then it was SQL, that means backend connectivity of Python with the SQL server. Is it right? Fine. Okay, we also understood like how to work under Flask framework to host a web page using Python and so on. Alright, fine. Here today we are at day 22. This is not 12 by mistake. Okay, day 22 of our analytics bootcamp, understanding a much awaited topic in Python, that is Numpy. Alright, fine. Okay, we will restrict ourselves to the usage of machine learning of Numpy in Python. Otherwise, Numpy to explore is a very big and a very deep ocean. Alright, fine. So it's absolutely fine even if you're a beginner and you're learning Numpy for the first time. Still fine. Still, let's go ahead and give it a shot. Okay, here we go, please. Small description about Numpy that we need to know before putting our hands practically on it and grab the keyboard. So here we go. Fine. Alright. Okay, Numpy stands first of all for numerical Python. Before I could read the points I have stated there on my presentation, guys, I would like to say Numpy is built on the top of Python list. I hope you're getting my point. Okay, you remembered list? It's a kind of data structure in Python that holds more than one element. Is it right? Like A equals to 10. That means we are storing just one value 10 in A. Okay, let me use my notepad, please. Okay, so when I write A equals to 10, that indicates you're storing the value 10 as data in memory variable A. Okay, you can't make A this way to store many values, 10, 20, 30, 40, 50, no. So that multiple values can be stored in a single variable. In Python, it is much needed to be declared it as a list. L-I-S-T list. Okay, so here we go, and this is how we declare a list under a square brackets. Is that correct? So A is now a list with total 5 element. Is that correct? And then further, I hope you have remembered the indexing in the list, because the same is going to be applicable today here with us. Like suppose there are 6 more or 5 more elements, 60, 70, 80, 90 and 100. So Python refer to this element in memory with their indices or index numbers. Is that correct? Okay, if I could use one sheet, just a moment please. Okay, like this is my list A, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Let me stop here. The index number of element in the list that starts from 0. I hope we all are aware of it. 1, 2, 3. Okay, this is not in our control. It's beyond our control. You like, you don't like. Indexing starts from 0. Always. This is how Python is designed to work. 4, 5, 6, 7, 8 and 9. So if the last index number is 9, that means the length of this list will be 10. Or vice versa, you can read. Say for example, the length of the list is 100. The last index number will be 99. because indexing starts from 0. Is that correct? And of course the negative indices and index numbers also exist, like here from the last, that is in the reverse order. If you start indexing elements, you have to start with -1, -2, -3 and so on. Alright, reverse order, indexing in the reverse order never starts from 0. Alright, so this way if I could continue, this would be -10. Alright, anyways, although we are not going to deal with any negative indexes today, we are just interested in the positive indices that goes in a normal order of left to right and starting with number 0. Alright, so in this past 3-4 minutes, what we have discussed is a very quick brush up of list in the form of a recap. Alright, then if you could go back and recollect all your memory that we have done that time in the classes. List comes with so many inbuilt function, like you can concatenate to list, you can split it, or maybe let me call it as you can find the you can arrange the list in ascending order, you can reverse the list and so on. Is that correct? Fine. So up until now we have seen how this list works, or in the form of a quick recap. Numpy is built on the top of the list, or let me say Numpy is used to create, this is what I've mentioned here. If I could take this point, okay, look at my third point here. It's a Python library used for working with arrays. Alright, now what happens is most other programming languages call this list like an array. Like if you talk about C, C++, Java, alright, they do not use the term list there. Instead, they call them as array. But in Python, list and arrays are two different data structures. I hope you're getting my point. Where array is built over the top of the functionalities of list. That means what list has, arrays will definitely have. Other than that, arrays comes with more additional functions and feature that makes our life easier. I hope you got my point. Is that correct? You will actually realize Numpy is like a blessing for all those people who are working in analytics or visualization or analysis outside. Alright, that's what is numerical Python, short for Numpy or full for Numpy. It was created by a small point of history. It was created by Mr. Travis Oliphant in the year 2005. Would like to add something more to this point. It's open source, that means it is free to use. Alright, okay, look at my fourth point. Numpy is really very fast. It works faster. That's one of the reason why it is preferred to work with large set of data. Alright, of course, after Numpy, when you will learn pandas, okay, you will find pandas like it comes with more feasibility, more features, more flexibility that even outpower Numpy. Alright, anyways, Numpy also provide other than array. Come on, so basic function of Numpy is what it helps you to work with array. And what are these arrays? Arrays are list kind of data structures. They look like list, but they have additional functionalities over list. I hope you got my point. Is it right? One more time, please, even if you have understood. They look more or less like a list, but they come with added power, added convenience, and added features, functionalities over list. Alright, what are all these? We will see in the day-to-day and coming up tomorrow. Alright, fine. Okay, other than array as one of the facility of Numpy, Numpy also provides some inbuilt functions for linear algebra and some random number generation. Alright, I have cut shorted my point and restricted it till here, whereas Numpy comes with several other features also, like Fourier transformation, this one, that one, etc. Alright, but this much is enough for us to understand Numpy, just to give it a kickstart. I hope you got my point. Alright, so let's see quickly how to import the library of Numpy and how to start working with its inbuilt functionality. Alright, see, Python as usual, as normal, Python doesn't come with all these packages inbuilt. You have to import them one by one. It's like, Python is like a normal engine and we just are fixing all these parts, somewhere Numpy, somewhere Panda, somewhere Scikit and so on, depending upon what is your requirement. I hope you got my point. Alright, so moral of the story, numerical Python Numpy It's hugely used in Python and analysis to work with arrays as well as to work with some random functions as well as for linear algebraic functions. Alright, fine. So here we go. Let's get our hands dirty on practical examples of Numpy. Okay, now what I have done here is to save our time. Just a moment, please. Okay. Here we go. A lot of stuff's open here. Never mind. Okay, to save a time, I have kept a lot of functions or a lot of code already written here. Let me execute this one by one. Okay, fine. So firstly, we say import numpy. Okay, as numpy or as np is an alias created here, so that everywhere we don't have to write numpy in full form. Even if you write just np, that will point to numpy. Alright, fine. So that is what is import numpy as np. For those who are wondering why so, okay, let me get the space please. Why so? Ignore this. This is for actually no reason. Even if you write like this, that's fine. Okay, even if you run this, it's fine. Okay, so import numpy and numpy has been imported. You could see today I'm working in a Jupyter notebook. This is again without any reason. You want, you can work in Visual Studio Code. You want, you can work in Colab. You want, you can work on Python idle one more time. I hope you got my point. Is it right? Hence on for numpy and pandas, I'm going to work in this Anaconda utility Jupyter or Jupyter notebook. Okay, so import numpy, but henceforth if you want to create an array using numpy, you have to write it like this: numpy.array, and inside whatever elements in the array that you want, so that every time we don't have to keep typing numpy as full word. That's the reason we should maintain the habit of creating alias, which is a short. Hoping you are understanding. Clear? So if I say enter, next time I'll just write here np. Okay, so that's my short form or a shortcut way of calling numpy as np. These are called as aliases, aliases. Okay, fine. Alright, so because numpy is an array, it has to be created inside the square bracket, and this is together called as an np.array function. Okay, so this array is a function present in the library numpy, module numpy, which creates an array that looks more over like a list. जो दिखता तो list है, but functionality list से भी बढ़कर है. Okay, ठीक है. So if I create an array like this, 1, 5, 6, 7, 10, or maybe 12, 34, 88. Okay, fine. So it creates an array and displays me. I could have stored this output in some variable like d is equal to, and then simply print d. I hope you're getting my point. Is that clear? Fine. Now this is a 1D array created by numpy. Alright, this is one added functionality of numpy, that it can be used to create n-dimensional array. Okay, now what is this n-dimensional array? First of all, try to understand this 1D array here. Now when I say d, it prints an entire array. But if I say d of 0, that means print element at index number 0 of this array. Is it correct? Exactly the same way how string and list used to work and deal with the indices. Even arrays deal with the indices. Alright, so d0, that means display element in the array d at index number 0. So if I say enter, of course, element at index number 0 is 1. Okay, element at index number 4, that means it should show me the fifth one. 1, 2, 3, 4, 5. Answer should be 5 or 10. Is that correct? Fine, but this is all about the 1D array. Now suppose if I want to create a 2D array. Okay, 2D array means what? It's like an array of arrays. Okay, so we have to enclose them even inside the square brackets, like 1, 2, 3. Okay, 4, 5, 6, 7, 8, 9. I hope you're getting my point. Okay, you can even continue 10, 11, 12, 13, 14, 15, or instead of number you can put some other strings or what, any other sort of value as well. I stop here. Okay, let me get rid of this and display just array D in the first attempt. Okay, so this is how the array looks like. This array is of the size, I think, 3 by 3. Am I right? 3 rows and 3 columns. You can consider each row as a list and column as individual elements inside the list. Are you understanding? I repeat the point one more time. You can consider row as an individual list and columns inside the row as individual elements of the list. Right. So now if I want to display 2, I can't just write 0 or 1 or 2 here. You have to deal with the indices in terms of 2 index number. Am I right? Like this. Have a look, please. I go back to my Excel sheet. One moment. Here we go. Where it is. Okay. So this is how we go. Say 1, 2, 3, 4, 5, 6, 7, 8 and 9. Alright, so this is an entire array called as D, wherein this is row number 0, this is row number 1. Okay, let me write it as 0. Row number 1, row number 2. Okay. Okay, alright. Fine. Control C, Control and Control. Okay, it's not copying. Let's not waste a lot of time. Okay, and then again. Got it? Fine. So this is row number 0. Now within row number 0, who is itself a list, this is column number 1. So this is how it will be indexed. So 0, 1 and 2. Alright. So if I want to access 2, how will I call it as D of 0? That is name or number of the list first and number of the element in that list next. Okay, like row first and column in that row as next. Right? So in order to access element 2, just look at the address. This is 0, 1. Okay, in order to access 6, this will be 1, 2. Is that correct? In order to access 7, this will be 2, name of the list first or index number of the list itself first, and then index number of the column or element in that list. Right? So index number of the list to whom 7 belong is 2, and index number of 7 within the list, that is 0. Hence 7 will be addressed as 2, 0. Alright, please raise your question in the chat box in case if you find confusing. I would be glad to repeat it back for you. Is that correct? Fine. So let's have a quick view of how can we do that. So if I write like this, 2, 0, that shows me 7. Okay, how does it show me 7? Because this is list number 2, or let me say list with index number 2, correct? This is a list with index number 2, and within the list 0 is a column that is for 7. Alright, fine. Okay, if you could see a list over here, or let me say an array over here created using Numpy, np.array. So I have total 1, 2, 3 and 4 lists within the array created, right? So if I say run this and show me B, okay, so array has been shown here. But if I write like this, b dot shape, after b, print b dot shape. Okay, print b as well as print b dot shape. Okay, so it says the shape of this array is 4,3. That means it is made up of 4 rows and each row inside contain 3 individual elements. Okay, one more thing to be noticed here is array cannot create a list inside of different sizes. Alright, like say this is what I want to say. The first list is 3, 20 and 99. And second list is, for example, 3, 4.5. No, one list has 3 element and the second list in the array has just 2 element. It cannot have. Understood? So even if you're writing the 2 element, it will automatically create the third one with a missing value. Understanding if and that's called as array contain always list inside of fixed sizes. It cannot contain of dynamic sizes. I hope you got my point, right? So let me call it as 6 here. Okay, fine. So 4 by 3, that gives us the shape of the list. That means it is made up of total 4 lists inside and each list has 3 columns. Okay, but excuse me for a moment. I just would like to see in case if there is any doubt. Okay. No. Fine. Let's go ahead from here. Okay. Okay, we're all set to go. Take it. Okay, fine. Let's go ahead from here. Fine. Moving on. Okay, that's what about b dot shape I talked about. Okay, and like 0, 2, 0, you can access 2, 1, 2, 2 and everything. Okay, one thing to be seen here is, suppose if I write 2, 0, it tells me 0. Why is it 0? Let me first print the list itself. Okay, let me first print the array 2, 0. Yes, correct. At list number 2, the first element is 0. Is that correct? So this is how it gives you the answer 0. Now suppose if I say 2, colon. That means colon indicates you want all the elements of that list. Okay, colon means all. Remember, if you don't specify the index number and write colon instead, that means you want to access all the elements. Alright, in the right side, if you're writing colon, I call this one as a left side and this one is a right side. Okay, on the right side, if you are writing a colon, yeah, that means you are referring to all the indexes within that list. And on the left side, if you're writing a colon, suppose here, that means you are referring to all the list themselves. Okay, like tell me what could be the meaning of this colon, 1. That means all the rows but with index number 1. Is that correct? Display all the rows where index number is 1. So let's check. What does it show? 20, because in the first row or first list, index number 1, at index number 1 there is 20. In the second list at index number 1 there is 4.5. In the third list at index number 1 there is -1. And in the fourth list at index number 1 there is 78. Are you understanding? Fine. So colon on the left side indicates all the list, and right side, if there is a colon, that means all the elements of the list. Alright, colon, colon, that means you are actually wanting to display all the rows and all the indices in those rows or entire array itself. Is that correct? So that's all about the meaning of colon here. Moving forward from here, okay, alright, I think I already mentioned the use of colon to you. Okay, moving forward from here. Okay, fine, if you just write b of 1, for example, that means it will display only the first row. Check it out. Is that correct? To verify it has done exactly the way we defined, print the list. Okay, so this is an entire list. I mean, this is an entire array of list wherein first row or the first element is this one, the first list. Is that correct? Fine. So if I similarly write here instead of 1, say 2, that means 0. This is the sublist at index number 1. This is the list at index number 2. Hence it is printed as it is. Right? Hoping you are understanding. Fine. Anyways, let's move on, please. Okay, this is something great if you could see. Okay, this is something great. Have a look, please. What will happen here? What will happen? No, this is something you will realize the capability of list capability of array over list. Or for example, if I create a small list or small array, okay, let me create a small array here. Say 1, 2, 3, 4, 5, 6, 7. I print this array. Okay. Now say I want to print only one element. Okay. And say I want to print 2 elements. It gives me an index error here. I hope you're understanding my point. Is it right? So that means you can't print 2 elements this way. Are you understanding my point here? Fine. So even if I write like this, it's done. That means you have to enclose it inside a list. But you see who is the element in array A at index number 0, that is 1. And who is the element at index number 3? 0, 1, 2, 3. That means it is 4. Is that correct? So we get an answer 1, 4. Now this is something list cannot do, but NumPy arrays can do. With list you can just display only one element at a time. Alright, you can't give comma and write multiple index numbers to display the elements at that position of the index number. Alright, I hope you're understanding what I'm talking about. So that is something about an exclusive feature of array over list, right? So if I write like this, what will happen? See how this will be open. This 0 and this 1 will be combined. Let me show you in some rough work first as a notepad file. Okay, now how this will be open? B 0, 1 will be one combination. Then B 1, 2, this will be another combination. And then B 1, 1, this will be the third combination. Right, so this is how we display the multiple elements in a 2D list or 2D array. I hope you're getting my point. Okay, multiple elements from the 2D array. This is how we display. Let's run this code and check whether it's happening or not. Okay, so let me print B first. Print B. Print B. Correct. So if this is an entire NumPy array, 0, 1, at 0, 1, that means list number 0, row, column number 1, 20. 20 is displayed. 1 and 2, so that means list number 1, this one, and in that list element number 2, that means 26. Is that correct? And the last one, 1, 1, that means list number 1, 0, and this is 1. Within list number 1, element number 1. So 0 and 1, that is 4.5. I hope you understand. Good? Acha. And suppose if I want to change the values, you can assign them this way. You look the way I have done here. Alright, because what will be this? Tell me 0 and 1. Who is 0, 1? 20. But 20 will be re-initialized as minus 10. Because this is an assignment happening over here if I am not wrong. Right? 1, 2 will be assigned minus 20 and 1, 1 will be assigned minus 30. Okay, fine. Have a look, please. Have a look. How does it look? Alright, so if I run this particular command, so this is my original array. Okay, but after replacing few elements at the respective index numbers, this is how the 2D array has become. Okay, 20 is no more 20. 20 is now been replaced by minus 10. That is 0, 1. At 1, 2, that is row number 1, 26, right? 1, 2, we have replaced minus 20. Okay, so this is how we reinitialize values in the array. Okay, so you can see that corresponding elements are now changed to new values. Is that correct? Fine. Okay, now you can also subset an array on the basis of some condition. Right? For example, if this is B, and I want to find how many elements in this, or who are, instead of asking the question how many, who are the elements in this array who are greater than 0. Okay, say I want to display, or I want to find out how many elements here are greater than 0. Say I have an array with all ages as number filled inside, and I want to find out how many ages in that array is greater than 18 so that they are eligible to vote. I simply write b greater than 0 or b greater than 18. Got it? So this is how it displays. Cool? Yeah, check it out. True, that means it is for 3. Yeah, 3 is greater than 0. False, because minus 10 is not greater than 0. This is the condition, right? 99 is true because it is greater than 0. Similarly, this way the last value of the array minus 19 has been displayed as false because it is again not greater than 0. Alright, now instead of getting this true, false everywhere, you only want your code to return who are those elements greater than 0, display them. Okay, enclose it inside. Alright, for example, if I write b of 1, it returns me the first row. If I write b of 1, 2, it returns me element at index number 2 in the first row. Similarly, if I write b of b greater than 0, it will return me all those elements who are greater than 0 in the array. Correct? So these are the elements. Alright, fine. Okay, so this is what is the meaning of b greater than 0. Instead of displaying the list in the form of true, false, true, false, true, false. Okay, this is how we have done. Okay, fine. What about this one? What will happen? B of 2 greater than or equal to 0. That means instead of checking entire array greater than 0, we are just checking the index number 2. List at index number 2 to be greater than 0, like this. Say print b. And who is the list in this array at index number 2? It is this list. Okay, so greater than or equal to 0, yeah, 0 is equal to 0. Minus 1 is not greater than 0, therefore false. And 20 not greater than 0, hence returned true. Right? Hoping you are understanding. Correct. Fine. Moving on to the next part. Right? Look, what will it print? What will this print? Say from all the rows, if the second row is greater than 0. Alright, so it will match the corresponding position from second row with respect to all the rows. Alright, like for example, we understand the output of this one, right? This is the output, b of 2 greater than 0. This is the second row, 0, 1, 2. This is the second row or the second list. When I say second means I'm talking about second as an index number, not the order number. Understood? As per the order, this is a third list in the array. But list at index number 2 or element at index number 2 will be the third one. Right? 4. So if you take the first list, alright, it will correspond to, with respect to the third list, come on, 3 greater than 0 because it is true. Minus 10 because it is false, so it will be omitted. 99 because it is true, so it will be taken. That means the first and third element, right? talk about this list. Come on, look at this list with respect to list number 2. Okay, so if I run this, that's what I said. You are getting first and third element of all the list, because for list at index 2 greater than 0, this is the format, or this is the order of the output: true, false, true. Hence this output is checked, or the other output is checked in corresponding to this output. Hoping you understand. Okay, drop me the message in the chat box in case if it is not clear, or even if you're watching these videos whenever in the form of recorded format and you are unable to understand, post it. Whenever we find time, we will definitely make it a point to reply you back. Is that correct? Okay, fine. What will happen now? What did I say? Did you remember? If the first colon on the left side, that means entire list. Colon on the right side means all the elements within that list. Correct? All the elements within that list. One moment please. Let me check if I have. Okay, here we go. No doubt as of. Correct? Fine. So colon on the left side indicates all the list, as well as colon on the right side indicates all the elements within that list. So what this code says, right? For all the rows, element at index number 2 if it is greater than or equal to 0. Is that correct? I repeat, in all the rows, display all the element at index number 2 if it is greater than 0. Right. So if I say yes, it says me true, false, true, false. Print the list first. So if I print it, this is my list. Now, in all the rows, first of all, take example of list number 1 in this array. Element at index number 2 in the first list is 99 and it is greater than 0. Correct? Element at index number 2 in the next list is minus 20, but it is not greater than 0, hence it has written false. Element at index number 2 in the third list is 20, which is again greater than 0, therefore written true. An element in the fourth list at index number 2 is minus 19, which is again not greater than 0, therefore it has returned false. Alright, so what will happen now if I put this entire thing in a Numpy array format? Okay, so it is, instead of returning me true, false, giving us all those values where this is true. Am I right? If you find here not this is true, all the rows, it returns me all the rows where second index number or element at index number 2 is greater than 0. Is that correct? Let's not confuse yourself. I repeat the point one more time. If I put it this way, that means it will return me all the rows, because colon on the left side indicate rows, right? So it returns us all the rows where element number 2 within the row is greater than 0. So if you could see element number 2 greater than 0, there are such two rows, the first and the third. Hence they are written from the array. Whereas the second list or the fourth list, index number 2, element at that index number 2 is not greater than 0. Therefore it is not written. I hope you got my point. Is that clear? Fine. Okay, this one you try. Okay, fine. In fact, we have talked more about Numpy in Python for like creating a Numpy array. We saw how to reinitialize the data in the array. We saw what is 1D array. We saw what are 2D array. We saw how to, let me say, subset an array based on conditions. What is the meaning of colon? How to deal with colon on the left side and how to deal with colon on the right side. Okay, fine. Let me deal with you another functionality of Numpy, that is some mathematical functions. Alright, now ideally what happens, this can be done using math library of Python, but this library or the functions in this library comes with some let me say flaws. I can't say flaw, but some shortcomings. Alright, there are some shortcomings. For example, I have imported this module of math, and this is my list or my array B. Check. first I would like to print B. And this is the list number 1 in B, correct? This is the list number 1. Okay, now ideally what happens is, check it out. Let me show you here. Okay, say I want to find absolute value of some number, say M, because M is an alias of math. M dot absolute of minus 10. What happened? Okay, because I did not execute this command. Okay, it's not yet executed. That's the reason it says M name not found. I hope you figured that out. Okay. Okay. Still not. Okay, I need to show that. Okay. Okay, it's not ABS, it is FABS. I hope you understand. Okay, ABS is something that Numpy array works with, not math works with. So if I want to find the absolute value of minus 10, this is how it gives me. Right? But suppose if I want to find the absolute value of, say this is an array or this is a list, 1, 2, minus 3, something like this. And if I find like this, A of 2, okay, it still gives me good. But if I would like to try something like this, say this is again A, okay, np dot array 1, 2, 3, I will just stop 2, 3, 5, okay. Alright, see, it doesn't show now. That means ABS, this function cannot work with more than one value. I hope you're getting my point. Is it right? And unless it is a scalar, scalar means a single dimensional array. It is ready to show an output. But if it is a two-dimensional array, it is not ready to work. Okay. Hence, instead of using math module, let's make use of NP functions to deal with this kind of numerical functions. Okay. For example, if I pass an entire list of or entire array of numbers to ABS, or ABS is a function of NumPy to return absolute values, the way FABS is a function in math module which also does the same thing. Alright, so if I return like this, okay, this is the absolute value. You can print it. So print first B. Okay, first print B and then print all the absolute values of B of 1. Alright, so who is B of 1? This is the second list. So absolute value of B in it is 13, this is 30, and this is minus 20, which is again 20. I hope you got it. Is that correct? Fine. Okay, students, this is all for the session today. Although I will continue with NumPy again tomorrow sharp at 5 p.m. Please stay tuned with us, stay connected. We are going to come up with a lot of new things, a lot of new courses, all absolutely free at the Code Ark, educating people out there of coding, artificial intelligence, machine learning, data science, and many more. Okay, a very quick recap of what we have learned today. We started with the discussion of NumPy, a theoretical discussion that stated NumPy stands for numerical Python. It's a module in Python that helps us to build array. Am I right? Array is a data structure that is built over the top of the list, means it comes with all the functionalities of list. Additional to it, there are more features. Okay, alright. Other than creating an array or allowing to create an array, NumPy also help us to work. It comes with also some linear algebraic functions one of such function or arithmetic function which we saw today working was ABS. Now tomorrow when I meet you, I will continue right from here, taking you to random numbers, how to generate using Numpy, sorting if possible, how to do with Numpy, and once Numpy is done, then we will go to how to use pandas using Python. Alright, fine. Okay friends, fine, stay connected, tune to us. If you really like our work, please like, share, comment, subscribe, and with your word of mouth, spread it to others as well. Okay, fine, that's all. Goodbye, take care.